Okay, let's have a look now at problem 7.51. This is what I like to refer to as a scenario problem. We're going to do some sampling distribution questions, but instead of just being given the basic facts and the numbers we need to use, that information has been represented in a scenario question. So we've got a bit of background information as well, and therefore part of our job in answering the question is to make sure that we know exactly what we're dealing with before we begin. Now, if we have a look at what we're been asked to work with, we're told that mutual funds reported modest earnings in the first quarter of 2004. International funds, which are historically slightly more volatile than US funds, had a mean return of 5.13%. So we've got a bit of background information. The main thing to notice at this stage is that we're talking about mean returns. So we know that our analysis is going to be based on means. Assume that the returns for the international funds were distributed as a random normal variable with mean of 5.13 and a standard deviation of 6. So we've got a population. We know that we've got the population following the normal distribution, and we know the mean and the standard deviation of that distribution. Now, if you select an individual fund from this population, what is the probability that it will have a return of, and our first question is less than 0. So that's equivalent to saying, what is the probability that it will have a loss? Now, in answering this question, the trick is we're talking at this point about an individual fund from the population. So really the wording couldn't be more clear. We've got some figures relating to a population. We want to find a probability. So this is just an X distribution, and really you could have answered this question as well as B and C from lecture 6. So if we work on A to start with, we're trying to find the probability that an individual fund will have a return of less than 0. Now, that is equivalent to finding the probability that X is less than 0. Okay? X is our random variable for the population. We know it's normally distributed. We know the mean of that distribution. We know the standard deviation. We're wanting to find the probability that X represents the return on an individual fund. So what's the probability that X is less than 0? Now, we don't have tables for the normal distribution where the mean is 5.13 and standard deviation is 6. So we know from our work in lecture 6 that we have to convert it to a Z distribution. So we have to find an equivalent probability in the Z distribution because we do have the standard normal tables. We've got tables for Z, but not for this particular X. So what we need to do is convert our probability that X is less than 0 into a probability of Z. Now, how do we go from 0 to an equivalent Z? Well, you use your X value, 0, you subtract the mean of the distribution, you divide by standard deviation. We need to find the Z score that corresponds to an X of 0. If you put 0 minus 5.13 divided by 6 into your calculator, the Z score comes out at negative 0.855. So if we can find the probability that Z is less than negative 0.855, we've found the probability that X is less than 0. This is an equivalent equation. Can we find a less than probability in the standard normal tables? Well, yes, all we need to do is look it up. And because this is a less than probability, it's just a direct lookup from the tables. The tables are based on 2 decimal places for the Z value, so you can round this off to negative 0.86. And if you look up the tables, you'll find that the area less than that is 0.1963. So that's the probability that we're looking for. So at this point, we're talking about populations, and really we could have answered these questions in terms of lecture 6. You might say, well, why are we doing them in Shoot 7? We've got these just to sort of go through and remind us of those ideas, and then we're going to use this same information and think about what happens when we take a sample of funds. So the questions in looking at populations first, we'll look at sampling distributions in the later parts, and we really just want to make sure that the difference between X problems and X bar problems is nice and clear. Okay, so that finishes part A. We can now have a look at part B. Part B is the probability that an individual fund will have a return of between 0 and 6. So if we look at our starting point in the working for B, we can see that what we're trying to find is the probability that X of course just represents the return of an individual fund. We want to know the probability that X is between 0 and 6. Now, it's a population question. We know the distribution of the population. The only problem, of course, is similar to part A. We don't have a table for that particular X normal distribution. So we need to convert the probability that X is between 0 and 6 into an equivalent Z probability. Now, how do we do that? Well, in this case, we've got to convert both 0 and 6 to equivalent Z scores. In part A, we've already worked out the Z score for 0. That was negative 0.855. So we can put that one straight in because we've already calculated it. But what about 6? What does 6 go to as a Z score? Well, to get that, we just say 6 minus the mean of the distribution divided by the standard deviation. And when you put that into your calculator, you get 0.145. So if we can find the probability that Z is between negative 0.855 and positive 0.145, we have the probability that we're looking for. It's an equivalent equation. Now, can we get that? Well, it is an in-between probability, but after lecture 6 and tute 6, you should be well practiced at those. We use the tables. We look up the probability that Z is less than 0.145. That area that we get is a little bit too big. We don't want the area that's less than negative 0.855, so we can look it up and take it away from the larger area. And what we end up with overall is 0.3614. So that's our probability. Again, a little bit more practice at populations when the population is normally distributed. One more just to go through the range of questions. Part C, we want to find the probability that an individual fund will have a return of greater than 10. So we're looking for, in part C, the probability that X is greater than 10. Now, same procedure. We say, well, that's the probability we want, but we don't have the X normal distribution table. We only have a Z table, so we must convert the probability of X being greater than 10 into an equivalent Z probability. Now, how do we do that? Well, we've done it a few times, but we'll go through it again with part C. You start off with the value 10, you subtract the mean of the distribution, 5.13, and then you divide by the standard deviation, which in this case is 6. So 10 minus 5.3, then divide it by 6. That gives you the equivalent Z score, and when that goes into the calculator, we find it's 0.8117. So if you want the probability that X is greater than 10, it's equivalent to the probability that Z is greater than 0.8117. Now, once it's in a Z probability format, it's just a matter of using the tables. Greater than probabilities, well, we can't find them directly in the tables. We've got to find less than, and when we've got the less than area, we can subtract it from 1, because we know the total area under the curve is equal to 1. So look up the probability that Z is less than 0.8117, and you can round that off to 2 decimal places. You're looking up the probability that Z is less than 0.81, and then subtract that value from 1, and you should end up with 0.2085.